Hello, we are going to look at the Born Haber cycle of sodium chloride. Whenever we are talking about a Born Haber cycle, we are dealing with formation of ionic compounds from their gaseous ions of their elements. So I want us to look at how we can form a Born Haber cycle of sodium chloride. First thing to note is that we shall have an energy level scale on the left hand side of our Born Haber cycle. So since we are starting with our elements in their standard form, I'll estimate somewhere here we have energy level being equal to 0 at the point where we have our elements. So since we are forming sodium chloride, the elements we need are sodium in its standard form and chlorine in its standard form as a gas. However, we are forming sodium chloride, and we know that enthalpy of formation is usually exothermic. So we shall have a downward arrow showing that we actually move in the negative direction on our energy scale. So we shall form our sodium chloride, which is a solid at standard temperature and pressure. So we shall put our half here to balance our equation. So this enthalpy is basically enthalpy of formation of our sodium chloride. So we need to find another pathway that can help us obtain sodium chloride solid, but not this direct route where we are forming sodium chloride. So we are going to try and ionize the sodium atom and this chlorine atoms. So the first step we shall do, we shall have to convert our sodium solid into sodium gas, after which we shall have to ionize it into a positively charged gaseous sodium atom. As you can see, we are moving up the energy graph, meaning that we are actually adding energy. So these reactions are basically endothermic. The same will apply to our chlorine atom. We shall have to split our chlorine molecule into a single atom because we need only one atom in sodium chloride. So we shall have our gaseous chlorine. So now the challenge is we need to know the energy changes that are actually occurring in between. So when we are trying to convert the sodium atom into a gaseous atom, this enthalpy is known as enthalpy of atomization of our sodium. So converting a sodium atom into its gaseous form is enthalpy of atomization of sodium. Then afterwards we shall add some energy until this sodium atom will lose at least one electron. So we are trying to ionize the sodium atom. So this is ionization enthalpy. So you can abbreviate it as IE, the ionization enthalpy of our sodium. So when you look at our chlorine, it's usually diatomic, but we need only one chlorine atom, so we have to somehow form a single atom. So just like we had enthalpy of atomization of sodium, this will be enthalpy of atomization of our chlorine. Let me just write the word chlorine. So now at this point we have finished ionizing sodium, we have finished atomizing the chlorine, but when you look at our energy scale, whenever we want to form a chlorine ion, usually enthalpies of electron affinity will be negative. So we are going to have a shift in our energy diagram. But one thing we had forgotten, when our sodium lost an electron, it has to be added at this level. We have an electron that was formed. So now our chlorine atom must pick this electron, so that becomes a chlorine ion, but usually that's accompanied by a loss in energy. So we shall have a downward arrow at this point where we shall now have our sodium in gaseous form plus our chloride ion after it picking that given electron. So how do we call this energy change? This is basically enthalpy of electron affinity. So you can say electron affinity. Our chlorine atom in gaseous form picking this one electron to form the chloride ion. Then when these two ions come together, the sodium ion and the chloride ion, to form sodium chloride, now this energy change is what we shall call the lattice energy. So these two can combine to form sodium chloride solid, and that's the energy change that we shall call LE, the lattice enthalpy of formation of our sodium chloride. So this is lattice energy. Basically, the lattice comes from the term a lattice that is formed whenever any compounds are formed, the 3D structure of that substance. So lattice energy, when these ions when these ions combine to form sodium chloride. So this is basically the Born Haber cycle. But one thing to notice is that the clockwise direction, when you look at clockwise, we are meaning these arrows that show upward movement and then downward movement in this direction. The sum of these enthalpies will always be equal to the anti-clockwise direction, the enthalpy of formation of sodium chloride. So I can briefly squeeze it down here and we see what we mean by that. If you want to find a given value of maybe the lattice energy, enthalpy of, electron affinity, ionization energy, and so on. So basically our enthalpy of formation of our sodium chloride is going to be equal to the following. So this is the anti-clockwise direction, this one here. Is going to be equal to the indirect route that we have just seen, the clockwise one. It will be equal to the enthalpy of atomization of our sodium plus the ionization energy of sodium, this one here, plus the enthalpy of atomization of chlorine, enthalpy of atomization of chlorine. Let us put a 2. Then plus the electron affinity, which has a negative value because it's exothermic, plus the electron affinity of our chlorine atom, then plus the lattice energy. So in case any of these is needed, usually they will give you the values of the others, so that you can just make it the subject and find its value. However, sometimes they may not give you the enthalpy of atomization of chlorine, but they may give you the bond dissociation enthalpy of chlorine. So in this case, if you are given bond dissociation, enthalpy of atomization of chlorine is half the bond dissociation energy of chlorine. So basically this is the Born Haber cycle, and you can use this relationship. The anti-clockwise direction or enthalpies will be equal to the sum of the clockwise enthalpies. So that's all about the Born Haber cycle of chlorine. But don't forget, the electron affinity and the lattice energy are basically negative in value. Yes, thanks for watching. Don't forget to like, share, comment, and subscribe. See you next time. Stay safe.